So this is for Integrated 3, Chapter 3, D-Day number 3. So on this, number 1, we have a system of equations. Both of these are y equal, so we're going to set them equal to each other. And when we do that, we want to check, since this is a square root, it is a principal root that we're looking for, that a principal root is going to be equal to, it cannot be negative. It could be 0, it could be positive, but it cannot be negative. So where I want to check is right here, this 2x plus 3, where my square root is isolated by itself, which it is. Whatever's on the other side, which happens to be 2x plus 3, that's where I'm going to check my answers that I get. So I have 24 minus 5x underneath the square root is equal to 2x plus 3. I'm going to square both sides. And when I square both sides, I end up getting 24 minus 5x equals, and on the other side, it is a perfect square trinomial. So I'm going to square 2x, which is a 4x squared. I'm going to multiply my 2x and my positive 3 together, which is a 6x, and then double it, which is a 12x. And then square my plus 3, so that's a 9. Now I'm going to get everything on one side, 0 on the other, so I'm going to have a 4x squared. I'm going to add 5x to both sides, giving me a 17x. I'm going to minus 24 from both sides, giving me a negative 15. Then I'm going to be doing a box and diamond. In the box, I'm going to have 4x squared and a negative 15. That multiplies to a, let me move this down a little, give myself more space. That multiplies to a negative 60x squared and has to add to 17x. So I have to be careful because I need it to be a negative. So really they have to subtract to get 17, not add, because they're both going to be different signs. So let's see. I'm going to say a 20x and a negative 3x. So I'm going to have a positive 20x and a negative 3x. And then I'm going to find the outside. Now, when I'm finding the outside, it could be a 4 and a 1 or a 2 and a 2. The 2 and the 2 is not going to work with the 3. So it's going to be a 4x and an x. This is going to be a negative 3. This is going to be a plus 5. So then I end up getting 0 is equal to 4x minus 3 times x plus 5, again, equals 0. I set each parenthesis to 0. 4x minus 3 equals 0. When I work that out, I'm going to get a positive 3/4. X plus 5 equals 0. When I work that out, I get a negative 5. Now, both of these, I am going to take and check up here to see if it makes it positive or negative. Now, putting in a positive 3/4 into 2x plus 3 where everything is positive, that will definitely work because that will be positive. So this right here will be an answer. Now, the other one, when I put in a negative 5, I'm going to get 2 times negative 5 plus 3. That's a negative 10 plus 3, which is a negative 7. That one will not work. So we have one answer. On number 2, we have another system of equations, but this system of equations is one that they want me to graph. So I am going to graph, I'll graph one of them in orange. So I'm going to start at, let's get rid of that, that's not part of this. I'm going to start at negative 2. And then I'm going to go up 1, 2, 3 over, let me hold on. 1, 2, 3 over 1, 1, 2, 3 over 1. And let me go backwards. And then I'm going to draw my line. That rectangle. I'm going to draw my line. And then I'm going to graph the other one. And the other one, let me graph in purple. Okay, so I'm going to start up at 5. I'm going to go down 1 over 2. So it crosses right there, down 1 over 2. And I'll just finish with my line. And when we are, again, trying to find the point of intersection, the solution to the system, it is the point where both of these graphs cross, which is right there. And that is going to be at 2, 4. So my answer to this is going to be 2, 4. That is the answer to the system of the equation. Number 3. Okay, so these ones we're solving. So on this, first thing I'm going to do on this one is I want to get this x minus 7 quantity squared by itself. I'm not going to work that out. I'm going to keep that and try to isolate that. So first thing I'm going to do is I'm going to get rid of the 11 by adding 11. So I get 3 times x minus 7 squared is equal to 48. So again, I still want to get this isolated. So I want to get rid of my 3. So I'm going to divide by 3, divide by 3. So I get x minus 7 squared is equal to 16. Now I want to undo that. So I'm going to square root both sides. So I'm going to take the square root of this side and I'm going to take the square root of this side. So when I take the square root of x minus 7 squared, I get x minus 7. When I take the square root of 16 myself, not where they have it drawn as a principal root, I need to give both options, a positive and a negative 4. And then I'm going to add 7 to both sides. So I'm going to have 7 plus or minus 4, which gives me 2 answers. One answer is going to be 7 plus 4, which is 11. And the other answer is 7 minus 4, which is 3. Those are our 2 answers. Now on B. B is a quadratic inequality. And so for a quadratic inequality, I want to have it have 0 on the other side. So I'm going to have x squared plus 5x. I'm going to minus 9, which is going to give me a negative 24. And then I want to factor this to see what would make it equal 0. Okay, that's going to give me my boundary points. So I'm going to have an x plus 8 and an x minus 3. So my boundary points are going to be negative 8 and positive 3. So on my number line, I'm going to have a negative 8 and a positive 3. And if I look back up here, this is less than or equal to, so that means I am going to actually have a solid line, dot at both of these. And either I'm going to shade in between or I'm going to shade out. I like to think of those points are what makes it 0. So those points would be like on my x-axis. And I have a parabola that opens up. So if I'm thinking of this as a parabola that opens up, I want where my x squared plus 5x minus 24 is less than or equal to 0, which means below the x-axis, where my output is below, is basically negative in this case. So again, let me just start drawing. I'm above the x-axis. I'm at the x-axis when I'm here at that negative 8. Below, 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 at. Above, 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 above. So where I need a shade is in between, because this is going to be less than or equal to. And so I can get rid of this parabola. That's not really part of my answer. I'm using it as a tool to figure out where to shade. And then I need to write my answer. When it's in this in-between form, start with the smaller of the 2 numbers, and then it's going to be strictly less than or equal to, in this case, less than or equal to x, still less than or equal to, they need to point the same direction, 3. Graph, answer. Need both of them. Okay, on letter C. So letter C is an absolute value equation. So for an absolute value equation, again, I need to, just like my square root one, I need to get my absolute value by itself. So I need to get rid of two things. I need to get rid of the -1 and then the 3. First, I'm going to get rid of the -1 by adding 1. So a 3 absolute value of x plus 4 equals 27x plus 15. Again, want to get this absolute value isolated by itself. Going to divide by 3. And on the other side, I'm going to divide each of these separately by 3. So I have the absolute value of x plus 4. Okay, now it's isolated, is equal to 9x plus 5. Now, when it's isolated, this is where I need to look and see, hey, absolute value always has to be a positive or 0. Can never be a negative. So this right here is where I am going to check my answers to make sure that I do not get a negative. So I'm going to write my two equations. One equation is going to be x plus 4 equal, and I just keep that other side as a 9x plus 5. And the second equation is going to be x plus 4 equals the opposite of that, which is a negative 9x and a minus 5. Okay, let me just rewrite that a little better. So negative 9x minus 5. So I'm going to solve both of those. So on this side, I am going to minus x from both sides and get 4 is equal to 8x plus 5. I'm going to minus 5 and getting negative 1 is equal to 8x. I'm going to divide by 8 and I get a negative 1/8. For the other one, I am going to add 9x to both sides. So I get 10x plus 4 is equal to negative 5. I am going to minus 4, so I get a negative 9. And I'm going to divide by 10, so I get a negative 9/10. And then what I want to do is I want to put the answer in and see what I get out. So let me just get Desmos right up here and make it smaller. So what I want to be checking is this 9x plus 5. When I put in my negative 1/8, do I get not a negative, basically? And then when I put in my negative 9/10, do I get not a negative? So I'm going to go 9 times negative 1/8. Oops. And then plus 5. That gave me a positive, so that one's going to be okay. Let me do 9 times negative 9/10 plus 5. That one gives me a negative. So my negative 9/10 is not going to be an answer. My negative 1/8 will. So again, this one here will be an answer because it did not make that negative when I checked it. This one did make it negative. So negative 1/8 is my answer. Okay, another type of situation we're going to see are these ones here where you have a base to a power. So 3 and 27. So just a little note, 3 to the third is the same as 27. That's the first thing I'm going to kind of also pay attention to. Second thing is I'm going to maybe let u equal the square root of x plus 1. So I can just rewrite this maybe in an easier form because I notice I have an x plus 1 here and underneath the square root and an x plus 1 here. So I'm going to let u equal that. So I'm going to just do 3 u squared equals 27 for raised to the 4 times u. Next thing I'm going to focus on is this 27 because 27 is the same as 3 to the third. So I'm going to rewrite that. So I'm going to have 3u squared equals 27, which is 3 to the third, raised to the power 4u, which basically means that they're going to multiply together. Power to power, I multiply. So now I have 3u squared equals 3 to the 12u. When I have the same base on both sides, so I have a base to a power equals a base to another power. What is true is that the powers have to be the same. So at this point, what I'm going to do is I am going to have u squared equals 12u. I am going to minus 12u from both sides, and I'm going to factor. And first thing I always do is, can I factor something out of every term? So I can factor u. And I'm going to get u minus 12 equals 0. So the two answers I'm going to get for u, I'm going to get u equals 0 is one answer, and u equal 12. Now remember, I did not have a u in my problem. So I am going to take this u, and again, over here, let me take that off for a second. This u equal square root of x plus 1, I'm going to plug it in there. So I'm going to do that in, let's say, orange. So I'm going to take 0 equal the square root of x plus 1. And always the first thing I need to do with a square root is go, hey, it's a principal root. Is it equal to basically not a negative? And it is. Having it equal 0 is fine. So I can proceed. So now I'm going to square both sides, and I'm going to get 0 is equal to x plus 1. I'm going to minus 1. And I get x. That is, I get x equals negative 1. For my u equal 12, I'm going to go 12 equal square root of x plus 1. I'm going to, and again, 12 is a positive, so I can work this out. So I get 144 is equal to x plus 1 when I square both sides. Just trying to rewrite my plus. Then I'm going to minus 1 from both sides. It still doesn't look like a plus to me. Okay. Then I'm going to minus 1 from both sides and get a 143 is equal to x. And so that is my second answer. So on letter E. Okay, I have a square root problem. Now for this square root problem, again, I want to check over here because my square root is isolated. So this over here, this x plus 1 has to be positive. I don't know what it is. I have to work it out and then plug in and double check. So I'm going to go 4 minus 2x underneath my square root equals x plus 1. I am going to square both sides. And so when I square both sides, I am going to get 4 minus 2x on this side. And this is a perfect square trinomial. X plus 1 quantity squared. I'm going to square the x, which is an x squared. I'm going to multiply x and 1 together, which is 1x, and then I double it, 2x. And then I square my 1, which is 1. So now I have a quadratic. I want it to equal 0. So I am going to add 2x to both sides, so I get a 4x. I'm going to minus 4 from both sides, so I get a negative 3. And then I'm going to factor that. And I want it to multiply to a negative 3 and add to a 4. And a negative 3 and a negative 1, but that is not going to add to 4. It's going to add to a negative 4. And so I think I'm going to have to solve this differently. So I'm either at this point, if I can't factor it, I am going to need to do either quadratic formula or complete the square. Myself personally, if this number here, if your B is even, I lean towards completing the square, especially if I have an x squared, not like a 2x squared or a 3x squared where I have a coefficient in front. So I am going to complete the square. So what I'm going to do first is bring my 3 over. Okay, equals x squared plus 4x. And then the 4x, I take my 4, which is my b, divide it by 2. which is 2, square it. So 4 divided by 2 is 2, 2 squared is 4. That's what I'm going to add to both sides. I'm going to add 4 to both sides because I got that from here, taking half of my b. So I'm going to have 7 is equal to the quantity x, and then half of 4x is, or half of 4, I should say, is 2. Then I am solving this. So I'm going to square root both sides. When I square root, I get a positive and negative. So I get a plus minus square root of 7. Not nice, so I leave it. On this side, I get an x plus 2. My very, very last step is I'm going to minus 2 from both sides. And those answers I need to check. Where do I need to check them? I need to check them up here to make sure I don't get a negative. Okay, so let me put it in my calculator. Okay, so I'm going to go this number plus 1. So I'm going to go negative 2 plus the square root of 7. And then plus 1. And that one's positive. So the plus root 7 part works. Now let me, here, I'm just going to copy it so you can see that one worked. I'm going to come down here, paste it, and this time put a minus in. That one did not work because I got a negative back and a principal root cannot equal a negative. So the one that works is going to be x equal negative 2 plus root 7. The one with the minus did not work. Okay, on number 4, solve each inequality and graph the solution on a number line. Okay, so this is a inequality. I want it to have 0 on the other side. So I am going to have 2x squared. I'm going to add 17x. And then I get my 0. And this one I'm going to factor. I'm going to do a diamond. And a rectangle. So I'm going to have a 2x squared and a 21. And that's going to be a 42x squared, but it has to add to a 17x. So I'm thinking 8x, 9x. 8x, 9x. So this is going to be a 2x. This is going to be x, x plus 9, 2x plus 4. So I'm going to have 2x plus 9 times x plus 4 equals 0. So x is equal to a negative 9 halves. X is equal to a negative 4. Those are going to be boundary points. Here, let me draw actually kind of a straighter number line. Okay, so I have a, hold on, negative 9 halves is actually negative 4.5. So negative 9 halves is actually going to be on the left side of negative 4. Okay, so I look back at the original problem to see, hey, is it open or closed circles? It's going to be closed circles because of the equal part. So I am going to have closed circles. And then I'm either going to shade in between or shade outside. So I'm going to think of this as that is where it is 0, which would be like my x-axis. I want to be less than or equal to 0. So if I think about this as a parabola, I'm above, at 0, below, at 0, above. So since I want it less than or equal to, it's going to be in between. And this is where I'm going to shade. Now, I don't really need this parabola. It was just there as a guide to help me figure out where to shade without having to test my points. My answer to this, I'm going to start with the negative 9 halves, less than or equal to x, less than or equal to negative 4. That's my graph and my answer. So number 5, we are trying to convert this to graphing form. So what I want to do first, I'm going to complete the square. So what I'm going to do first is I'm going to minus 3 from both sides. And then what I'm going to do is I'm going to look at my b, which is this -8. And I'm going to say, okay, I'm going to take -8. I'm going to divide it in half, which would be a -4. And then I'm going to square it. And when I square a -4, I get a 16. So I'm going to have y minus 3, x squared minus 8x, okay? And I am going to add 16 to make it into a perfect square. So I'm going to have y plus 13 is equal to, and x squared minus 8x plus 16 is x minus 4 squared. Half of -8 is -4. That's what goes in that parenthesis. Then I'm going to minus 13. And that's the nice graphing form. Okay. On number 6, decide if the function is even or odd. Show your work. Okay. So if you take a function and put in -x and you get back exactly the same as the original function, this means it is even. If you take -x and put it in for your x, and you get back the opposite of the original function, that means it's odd. If neither one happens, it's neither. So I am going to take f of -x and into x squared minus 3 times x to the 10th plus 16 times x. I'm going to put in a -x. So -x in parentheses squared. -3 times a -x in parentheses to the 10th power, and 16 times a -x. So when I raise a negative to an even power, I get a positive. So that's going to be positive x squared. In this next one, a negative, so I'm focused right here on this, a negative x to the 10th. This right here is going to be a positive x to the 10th. So I'm going to have a -3 times a positive x to the 10th, which is a -3x to the 10th. And then my 16 times a -x is a -16x. So what I want to do is I want to look back up at the original problem. Okay, so I had an x squared there, I have an x squared here. I had a -3x to the 10th in both of them. Now, this is where there's a problem, this -16x. That is not the same, so it's not even. It is opposite, but everything else is not opposite. So this is going to be neither. Why? It's not opposite, and opposite would have been odd. And it's not even, I mean, not same, and same would have been even. So if I had wanted the opposite of this, the opposite would have been a -x squared plus 3x to the 10th minus 16x. The only part of that I got was the -16x. So it was not opposite, and it was not the same because the -16x was not a +16x. Okay. These last ones, I'm actually going to grab a graph. So I'm going to go to add media, go down to the G for Google search, and I'm just going to type in graph, and I'm just going to grab this one. Okay, put one here, and I'm going to come up here to select annotation, click on it, copy, paste. I'm going to put this one over here because this one fits here nicer. And I'm going to paste again. Now this one is a little too big, so I can't make it smaller until I come here to the select, and then I can make it a little smaller. There we go. Okay. So on number 7. So on number 7, I'm just going to move this up a little. This is a reciprocal function. And if you want to think of a critical point, you could think 3, 4, but that critical point is not an actual point on the graph. It's where my vertical asymptote, which is going to be at x equal 3, because that's what makes this denominator 0. And my horizontal asymptote, which is y equal 4, because of this plus 4, it's where they will meet. Okay, that's what that is. So let me just draw in my xy axis. Okay, so I'm going to draw. And so if I went to that point, 1, 2, 3, 1, 2, 3, 4, and put a point here, you're going to see that this is where my vertical and horizontal asymptotes meet. So I am going to have a vertical asymptote at x equal 3. I'm going to have a horizontal asymptote at y equal 4. And then we're sketching this, but for the sketch, if you go to, because there's a 1 on top, so whatever your number is on top for these, basically your x and y distance from that kind of like, well, so from that, this point right here, this 3, 4, where the two asymptotes meet, those two distances multiply to the number on top. So in this case, my top number is 1. So I'm going to go over 1, up 1. Because 1 times 1 is 1. And the other direction, a -1 times a -1. That's going to be kind of the 2 points that I'm going to actually graph. And then the rest of it, I'm going to just draw in. And it gets closer and closer to those asymptotes. That is my first graph. My second graph is a square root graph. And that graph is half of a sideways parabola. It's going to be the positive root because it's the principal root. And so 1, 3 is going to be kind of the starting point. Would be like the vertex if we drew the whole entire parabola. Okay, so I'm going to scooch this over this way, give myself a little room to the right. And here, this is okay. So I'm going to go to 1, 3, 1, 1, 2, 3. And then from there, I'm going to be thinking, hey, what are nice numbers to square root? So if I go out 1 from my start, square root of 1 is 1. So I'm going to go 1, 1. I mean, not 1, 1, but out 1, up 1. From my starting point, if I go out 1, 2, 3, 4, the square root of 4 is 2. So I'm going to go up 2. Next nice number, let's say 9. So I got 1, 2, 3, 4, 5, 6, 7, 8, 9. Square root of 9 is 1, 2, 3. Okay, those are going to be kind of the nice ones I can graph. And then I can draw my square root. Now, the last one is an exponential graph. And an exponential graph, I will write a critical point or a locator point 4, -3. But this point, again, is not actually on my graph. I am going to have, because of this -3, a horizontal asymptote at y equal -3. Okay, so let me first graph my xy axis. Okay. So I am going to have a horizontal asymptote at x equal -3. So let me draw my horizontal asymptote in at y equal -3. And then if I'm thinking about that point, I'm just going to do it in, let's say, orange. It's not going to be part of my graph, but I just want us to see. So if I go to 1, 2, 3, 4, comma, -3, this right here, this is where I'm going to be starting my graph. Okay. And you always start your graph one above, unless you have a number outside that's multiplying your base to a power. So I don't. So I'm going to come over here. Let's say I do it in pink. So I'm going to come here to basically 4 to the right of where my asymptote crosses the y-axis. And I'm going to go up 1. Okay, that's kind of my start. And then I'm going to go over 1. And since my B is 2, that means I'm doubling. So if I was 1 high, now I'm going to be 2 high, then 4 high, then 8 high, then 16, okay, and let me just get rid of that orange point. It's really not, it's just was helping me kind of figure out where I am. And then I am going to draw my curve like that. And that's my exponential. And that's the end of this video.